Dear students, welcome to the video lecture of software quality assurance and testing. We are going to discuss about the test strategy. So in this session, so software quality assurance and testing, I are going to discuss about the test strategy. The extent of testing a system is corrected by many factors. First, you should know what is testing. Testing is to run the software. The intention of to finding the error is known as a testing. The context of testing a system is controlled by many factors such as risk involved, limitation on resources, and deadlines. A test strategy should find the defects in a product within given constraint. A test strategy should find the defects in a product within given constraint. There are many testing strategies such as black box testing, white box testing, top-down testing, and bottom testing. There are many testing strategies such as black box testing, white box testing, top-down testing, and bottom testing. No strategy or combination of strategy prove the correctness of the system. No strategy or combination of strategy prove the correctness of the system. It can be established only its acceptability. So we are having a different kind of testing, such as black box testing and white box testing. So we are going to discuss about the black box testing. So black box means as a fully covered box. You cannot see what is inside it. That is known as a black box. Like that, the concept of the black box is used to represent the system that's inside working are not available for inspection. In black box testing, we try various inputs and examine the resulting output, though which we learn that what the box does nor how the conversion take place. So just we are only we try the various inputs and examine the resulting output. That's it. You don't know what is happening inside, what the box does and how the conversion take place. That means that the logic is unknown. The test item is treated as a black box since the logic is unknown. Black box test works very nicely in testing objects in the object-oriented OO environment. Black box testing works very nicely testing objects in an object-oriented environment. The black box testing can be used for scenario-based testing. The black box testing can be used for the scenario-based testing where the system inside may not available for inspection. In black box testing, we are giving some input and we check the output. We are comparing the expected output to the actual output, but you don't know what is the logic inside it. Such a kind of testing is known as a black box testing. It can be used for the scenario-based testing, where the system inside may not available for the inspection. So input output only visible is input output, but what is inside the logic is unknown. This kind of testing is known as a black box testing. Next, white box testing. So white box means transparent box. You see what is inside it. You see what is inside it. Then you see the the logic. Such a testing is known as a white box testing. White box testing. The main use of the white box is error-based testing. Assumes that the specific logic is important and must be tested to guarantee that system's proper functioning. The specific logic is important and must be tested to guarantee that system's proper functioning. It assumes that specific logic is important and must be tested to guarantee the system proper functioning. Again, I'm emphasizing this. Okay, I assume that specific logic is important and must be tested to guarantee the system proper functioning. The main use of the white box testing is an error-based testing. The main use of the white box testing is an error-based testing. Two types of path testing. First one is statement coverage testing. White box testing, also known as a path testing, which contain two types. One is statement testing. One is statement testing coverage. Second one is branch testing coverage. Statement testing is to test every statement in the objects. Every statement is tested in the object methods. Every statement in the object method is tested by executing it at least once. Every statement is get executed at least once. It is unfortunate to test the program on every single input. It is unfortunate to test the program on every single input. So you never can be sure that a program will not fail on some input. So you never can be sure that a program will fail on some input. Second one is the branch coverage testing is to perform enough tests to ensure that every branch alternative has been executed at least once under some test. So branch means the decision making statement, if else statement. So every branch will get executed at least once. A statement testing coverage, as in statement testing coverage, it is unfeasible to fully test any program of a considerable size. Okay, it's not possible to test. That's why the branch testing coverage plays an important very role. If it is a branch, that means that every decision loop, if loop and else loop, if block and else block will get tested. As an iteration means every statement testing iteration, every statement will get tested. So that is the statement coverage. We are testing and checking all the statement of the object at least once. Branch coverage, every branch decision making statement is tested at least once. If else contain, okay, we will give a data to test the if part and as well as else part also. So we are having another testing that is known as a top-down testing and the bottom-up testing. Top-down testing assumes that what is top-down testing and what is the bottom-up testing. So top-down testing at the high level, to see in the high level, okay, it is an entire system. To see in the lower level, which contain the objects. So top-down testing from the start from the system and moving on subsystem, and again a subsystem and moving towards the object. Bottom-up testing starting from the individual objects and just a subsystem and finally entire system. This is a top-down and bottom-up testing. Top-down testing assumes that object interactions and the system's messages of the application need more testing than the individual objects methods. Top-down testing strategy can be detect the series of design flaws in the early implementation. To detect the series of design flaws in the early implementation. Top-down testing should find the critical design error early in the testing process and significantly improve the quality of the delivered software because of the iterative nature of the test. Top-down testing strategies support the testing the user interface and the event-driven systems. This serves a two purpose. First, the top-down approach can test the navigation through the screens and verify that it matches with the requirement. Top-down approach can test the navigation through the screens and verify it matches with the requirement. Second, the user can see at an early stage how the final application will look and feel. This approach also is useful for scenario-based testing. Top-down testing is useful to test the subsystem and system integration. So this is a top-down testing. So everything is transparent only, and input, output, and system logic are got tested. This is a part of white box testing. Next, bottom-up testing. Bottom start from the objects and finally move to the system of higher level systems. Bottom-up testing starts with the data of the system and proceed to the higher level by a progressive aggregation details until they collectively fit the requirement for the system. Okay, start from the individual object and proceed to the next higher level subsystem, next higher level system until they collectively fit the requirement of the system. The approach is more appropriate for testing individual objects of the system. Each objects are tested and then combine them. Each objects are tested, combine them, and test their interaction messages passed among the objects by replacing the top-down approach. In a bottom testing, first test the classes and methods thoroughly, then progress to the next level. Next, combine the bottom two layers and proceed until you test the entire program. That is bottom. Start from the object, test the individual object, and combine them, and test the next high-level system, and combine them, and test the next high-level system. It will proceed like this. Bottom testing. This is more appropriate for testing individual objects in a system. So bottom testing is more appropriate to test the individual objects in the system. The strategy makes sense because you are checking the behavior of the piece of code before it is used by the another. It is a more appropriate testing strategy. Bottom testing leads to integration testing, which leads to the system testing. So bottom testing leads to integration. Means first individual objects, then we can combine the subsystem which contains the set of objects, then the system, it will go like this. Every phase we are checking the integration between first individual object, then for example set of objects, then next level higher set of objects, okay, then subsystem, then system. So every phase we are testing the integration testing, which leads to the system testing. So that's it for the video lecture. So we discussed the testing strategies. So in this we covered the black box testing, white box testing, and top-down testing, and the bottom-up testing. Thanks for watching the video lecture.